Good morning, students. So in our last class, we complete up to question number 12 from the exercise 6.5 chapter application of derivatives, isn't it? So here some more questions are remain. I think 2 or 3 questions are remain from the algebraic part, and we have to complete these 3 questions. So as you see here, question number 13, and the question is given like in this way: find two numbers whose sum is 24 and whose product is as large as possible. The product is as large as possible. So when this type of questions are given, so the product is given the sum of two numbers whose sum is how much? 24. Okay, now in this case, if this type of questions are given to us and the product is as large as possible, so that means the meaning of as large as possible, that means here we have to find out the maximum value. Not only the maximum value here, when the value is maximum, we have to find out the numbers. What are the numbers here? And the condition is given here, the sum of the number is how much? 24. So now in this case, what we have to do here, we don't know the numbers, so that's why first of all here, if we consider, let the first number, if one number be x, so obviously the another one is how much? So obviously another one is 24 minus x, because their sum is given here, their sum is given 24. So that means if one number is 10, so another one is 24 minus 10, 14, isn't it? So that's why here the first number we don't know, so that's why we consider x. So that's why here the another number is how much? 24 minus x, because their sum is given 24. So now here, according to our condition here given, product is as large as possible. So that's why in this case what you have to do, if we consider the function, let fx equals to, fx equals to their product, we need first their product. So that's why if we multiply these two, then we write here x into 24 minus x. So if we multiply these two, now here f of x, if we multiply these two, then here we get this one is 24x minus of x square. So now from here what you have to do, the function we get, and the condition is given as large as possible, that means from here we get the maximum value. So that's why now the general step, we know what you have to do after getting the function here, we have to differentiate this one. So that's why therefore here you have to write therefore f dash of x. So therefore f dash of x equal to ddx of 24x. If we differentiate, then we get this one is 24 and minus ddx of x square equal to how much? This one we get twice x. So this one is the differentiation part. And after that what you have to do, now the general step we know, we have to write f dash of x equals to 0, isn't it? So when we write f dash of x equals to 0, in place of this f dash of x we have to put this value, and then when we put this value, then 24 minus of twice x equals to 0, or rearranging this result, so twice x equals to, we get 24, and from here we get x equals to, we get 12. So now let's say here we get the critical point. The critical point is how much? X equals to 12 we get. If the critical point is 12, we don't know at this critical point we get maximum or minimum. So that's why first of all what you have to do, we have to verify this result. For verification, since it is an algebraic function, so easily we can apply here the second derivative method, as not it. So that's why for this what you have to do, we have to differentiate the result again. So that's why again differentiating. So again if we differentiating this one with respect to x, so the differentiation part is this one, f dash of x equal to 24 minus twice x. So this one again we have to differentiate. So if we differentiate this one with respect to x, now in this case you see ddx of 24 constant term 0 and minus 2 constant term, and ddx of x is what? 1. So ultimately if we differentiate this result, again what will remain here? So that's why here remain f double dash of x equals to minus 2 remain. After differentiation we get this result, f double dash of x equal to minus 2. Is it clear? Okay, now here we have to verify this one. Now what you have to do, put the critical point is how much? The critical point we get x, so that's how we have to put this x value, x critical point here. So that's why put x equals to 12. So put x equals to 12, therefore if we put, then f double dash of 12 equals to, now there is no x, so that's why simply we get here minus 2. That means which one is Negative value means less than 0. If less than 0, according to our second derivative condition, we know we get maximum value, as not it. So according to our question, as large as possible, as not it. So as large as possible mentioned. For that reason, what you have to do, we have to verify this one, and at which point we get maximum? At 12 we get maximum. So from here what we can say? So from here we can say, so fx has maximum. So fx has maximum at x equals to 12. That means as large as possible. So here one number we get 12. So what will be the another one? So that means here already we consider x and 24 minus x. So if one is 12, so in place of x, again if you put 12, 24 minus 12, again 12. So that means here the numbers are what? 12 and 12. Is it clear? I hope all of you understood this one. Very simple question here. Just according to our question we solve, and finally we get the numbers are what? 12 and 12. Is it clear? Okay. After completing the question number 13, if you see the another question number 14, and if you see the question number 14 is given here like in this way, find two positive numbers x and y. Same question, same type of question here. This one is given. Find two positive numbers x and y such that x plus y equal to 60 and xy cube is maximum. So now here in the earlier question given as large as possible, now in this case given xy cube is maximum. So that means the meaning is same here. So first of all, the two numbers are here mentioned, x and y. So if we convert this one into one function, so that means here first of all you see we have to find out when we have to solve this one. First of all, here two numbers are given. The two numbers are given here x and y, isn't it? And here also given what? The sum x plus y equals to 60. The sum is 60 given. So from here if we find out the value of y equal to how much we get here? 60 minus x. So that means if one number is x, so another one is how much? 60 minus x, isn't it? And here the condition is given xy cube is what? Maximum. So for that reason here, first of all, if we consider the function, let fx, so fx equals to, if we consider this one is xy cube, if we consider the function is fx equal to xy cube, actually here we can't write xy cube because it is a function of x. That means all the values are here, we need x. So that means in place of y we have to replace this y by 60 minus x. So that means we have to write this result, fx equal to, we have to write this result directly, fx equals to x, y cube means what? This one we have to write here 60 minus of x whole cube. Is it clear? So y means 60 minus x, so that means 60 minus x whole cube we have to write. So here no need to break this whole cube part here, so we can directly differentiate, because here the function we get now here. After that, all of you know what you have to do. We have to differentiate this one. So when we have to differentiate this one, so therefore if you see f dash of x, so f dash of x, so using here u into v formula, is not it? If we apply u into v formula, so easily we can differentiate this result. So first of all, what you have to write? We keep x, and then we have to differentiate d dx of 60 minus of x whole cube, isn't it? Plus of. Then the second one we have to write here 60 minus of x whole cube, and we differentiate d dx of x. All of you know this formula, u into d dx of v plus v into d dx of u. So if we differentiate this one, now in this case what you get? X. Now here 60 minus x whole cube. That means if you differentiate this one, then we assume this part as an x, so that means here it is of the form x cube, and then what is the answer? 3x square. So x means here we have to write 60 minus of x whole square. But if you see here, this one is not x, so that's why again we have to differentiate this. d dx of 60 0, d dx of x is minus 1, so ultimately here remain minus 1. Plus of, in the second case here d dx of x means 1, so no need to write here, so simply here we write 60 minus of x whole cube. Is it clear? 60 minus x whole cube we write. So ultimately here what we get here, if we write this one first, So here 60 minus of x whole cube, 60 minus of x whole cube, here minus is there, so minus 3x into this one we write 60 minus of x whole square. Is it clear? So this one is f dash of x. I think all of you understood this one here now. So f dash of x equal to, we get this result. Now after that the next step is what? F dash of x equals to 0 we have to write. So that's why here we write now f dash of x equals to 0. So f dash of x equals to 0 when we write, so in place of this f dash of x, now we have to put this value. This value is what here? 60 minus x. So now here 60 minus of x whole cube, 60 minus x whole cube minus thrice x into 60 minus of x whole square, isn't it? Whole square equals to 0. This one we have to put here. And now from here what you have to do, we have to find out the critical point. So when you have to find out the critical point, first of all here in both cases you see what is common. So if you see here 60 minus x whole square, 60 minus x whole cube, so that means here 60 minus x whole square is common. So if you take this one common, 60 minus x whole square, if we take common, so here cube, so that means 60, simply 60 minus x is remain here, as not it. So in this second case 60 minus x whole square already we take common, so that means what will remain here? Minus thrice x. So that's why here we have to write minus thrice x equals to 0. Now in this case if you see here their product is equal to 0. So their product is equals to 0 means we can write here either 60 minus x whole square, so 60 minus x whole square equals to 0, or we can write here what? Or we can write here 60 minus of x minus of thrice x equals to 0. We can write these two results. So from here if we calculate what we get 6x equal to 60 here, and if you calculate this one x equal to, we get 15. So that means how many critical points are we get here? One is 60 and another one is x equals to 15. If you calculate this one, minus x minus thrice x minus 4x, so that means ultimately we get 15. So that means if you see here two critical points are we get x equal to 60 and x equal to 15, as not it. So after that all of you know what you have to do. We have to verify these two results. And how can we verify these two results? So whatever the f dash of x function we get this one, you see here this f dash of x, again we have to define set. If we define set this one, then we get second derivative result, and in this second derivative result we have to verify these 2 points, these two critical point we have to verify, or we have to check out whether it is maximum or minimum. And when we get maximum, this one is our required numbers, and the numbers are what? X and y. Y means what? 60 minus x. So from here we have to verify which one is maximum, 15 or 60, and after that we have to, after verification, in place of x we have to put this value, and as well as we have to find out the value of y also. So the second part is your task. You have to solve this question and write these two questions. I think today 13 and 14, these two questions are we complete here. So you have to copy these two questions properly. And in our next class, we continue this exercise. I think another two questions are remain, 15 and 16. So in our next class, we have to complete these two questions. Is it clear? Okay. Thank you.